after you get past all of the node information, you're going to run into the element information. What's the element information going to look like? The element information is way down at the bottom. It's going to say element 1, and then it's going to say is defined by node 1, by node 2, by node 3, by node 4. If it's a tetrahedral mesh, so basically a pyramid type mesh, it'll give you 4 node numbers that are all connected together. So this file can be just saved off your drive, and then you can take that file and manually hand it to ANSYS if that's what it was written out as. If it was written out as MSC Nastran, you could take it and hand it to MSC Nastran and solve it. If you don't want to write it out, you just want to go and solve it, if it knows the path to where the ANSYS executable is, or knows the path to where Abacus is, you'll just go and solve it and return the data right back to your CAD system. The fourth step in doing find an element on a CAD system is really tied to viewing the results and interpreting the results. And generally, it'll come up with images similar to what is on the screen. And it will generally give you kind of a tree structure. And inside of that tree structure, it lists all of the other images that were pre-calculated. So can you get the von Mises stresses? Yeah, you just have to find it in the list. Can you get the maximum stresses in the x direction or the y direction, the principal stresses? Can you get it, principal? Yeah, you just have to find it on the list and click on it, and the image will change. There's also options, usually right there, where you can animate it. You can say, make a movie of this thing. And you can exaggerate the deflection, or you can minimize it so that it's really not looking like it's a diving board. So here are some other examples of just clicking on different images. Oops. There's 2 of them, 2 different ones to go through. The modern CAD systems have an ability to output a data file. And so generally in your menu someplace there's something that looks like a report, a scroll with text on it. If you click on that icon, the report icon, it will generate a 10-page document wherein it has all of the information on all of the stresses, and any of these images in the tree that you want printed into that report. You basically say, save this image, save this image, save this movie, show me this text data. You basically specify, and it builds a document that you can basically send as an attachment to an email to a counterpart in your company or people outside your company, and it makes viewing and understanding and interpreting the data very easily. These links, unfortunately, are broken, and I didn't have time. I thought they were working the last time I was here and checked right before coming down here. I've moved the files, but I was going to show you what that actual report looks like, but it just saves it off to your drive. And then you can click on it. It's an HTML document, or you can save it to Word, and it's a very nice collection of all of the cases. So we've been talking kind of one case. You can set up all kinds of load cases and all kinds of different analyses that you want to run on a single part and build that into a single report file. Questions on doing the find an element? So I'll ask one. how much finite element do each of you have to do as it relates to the final project? So as a minimum, I'm expecting each of you to choose a part different than your team members, choose a part and do a realistic FEA analysis of that part. Okay. Put in realistic loads, set up realistic boundary conditions, realistic constraints, realistic material properties, and go through the process of generating a result. And if that result suggests that you need to modify your design, modify its thickness, modify, parametrically adjust your part, then I would expect that to be part of your discussion of why you did finite element. I did finite element, and clearly we have a much thicker part than we need to, and you adjusted the thickness, you re-ran the part, and you looked at it and said, I'm easily within a safety factor of 2. If you're within a safety factor of 11, you need to do some modification to your part because it's way too heavy. Okay. So I expect at least one story from each team member tied to some analysis and modification of that part. Okay. If you have more time, do more. It's your portfolio that you're building. It's not mine, it's yours, so that you can hold it up and say, here's what I did, here's what my whole team did, but I did these things.
This is just a question about when you're actually doing it for your part and you're deciding if you are going to change things about the geometry or whatever. How do you go about actually finding the loads of these teeny parts and these small weights? You know what I mean? To me, it seems like most of the time, for the size of the car, they're small loads. Maybe should we bring them up to if it was a bigger car or what?
No, I would try and keep it just what it is. And so here at BYU, we have scales that you can drop all of the parts on, put a whole collection on there and say, this thing ought to weigh this amount, and then figure out where to locate that. We probably have a radar gun that we could hold on the car when it's fully, charged. We could say its speed is this, and knowing its speed and knowing its weight, and then saying it's going to hit a brick wall. You can translate that into a load, and you can begin applying that. The one thing we can't quite figure out is going to be what? Material properties. And so we can say, well, it's a plastic. Well, what kind of plastic? Well, let's assume that it's a thermal plastic. So you can make some guesses that way. But again, when you're making the presentation, you say, we measured this, we did this, we calculated this, but we're guessing at the materials because we're not sure what that was. But even based on your choice, you can still say, we need it thicker, we need it thinner. If we need it thicker, then maybe we didn't choose the same material that the actual manufacturer did. Or vice versa. We want it thinner. Again, we may have chosen material that was different than what the manufacturer did. Again, it's an attempt to have this be a real thing that you can walk away from this class and talk about. Other questions? So, have you been reading the chapter? Has it been making sense to you? Anybody dived into the chapter yet? Okay. You need to make sure that you're reading the chapter. Next week, we take one day and we talk about assembly, finite element modeling. And so, what happens when I have a full suspension and upright and a tire and everything else? How do I put a load on the tire load all the way through an assembly. So we're going to be talking about assembly on an Alpha Pop on Tuesday of next week. All right, we're done. That's it.
I just pulled up. Well, I think